series. There we go. Now you guys can hear me. All right. We are 15-minute tech talk on series ratings. We're starting a few minutes. I wanted to do this exactly at 5, and I'm a little late. So if you're out there listening, thanks for chiming in and hanging in there for me. And we're going to start this 15-minute technical talk on series ratings. And if you've seen my last two, this is my third one. The first one I've actually posted ahead of time, maybe a day, or no, actually this morning. We're going to talk series ratings, and how I do this is I put 15 minutes on the clock. I queue up the PowerPoint, hit 15 minutes on the clock, and I'm hopefully going to get done before that 15 minutes is over. So let's queue this up. Whoa. All right, here we go. Series ratings, and let's do 15 minutes on the clock, and there we go. All right, so series ratings. Let's talk a little bit about what series ratings are, why we would go down the road of doing series ratings, and then what are the gotchas, what are the things that we need to think about when we do a series rated system. All right, I have a changer around here somewhere. And look at that, I'm eating up time. It's down here. All right, so and it's off. Talk about not being prepared. I was just on a conference call. Interrupting ratings. So we have to understand, we talked yesterday about short circuit current ratings. And if you're not familiar with that, take a look at the 15-minute tech talk on short circuit current ratings that I did yesterday. Today we're going to talk about interrupting ratings and a specific type of installation. When we talk about interrupting ratings, we're speaking to series rated systems. Now remember, from an interruption perspective, 110.10 of the National Electrical Code tells us that the overcurrent protective device or devices shall be selected and coordinated to permit the circuit protective devices used to clear a fault to do so without extensive damage to the electrical components of the circuit. So I've got to make sure that I stop the flow of current. I can't have damage to myself. I can't have damage to the equipment downstream. That's a short circuit current rating. That is section 110.10. So remember, in 110.10, we say the overcurrent protective device has to be coordinated to permit the circuit devices to clear the fault without damage to the circuit. And that's why we call that a short circuit current rating. Interrupting ratings are when is the rating of the overcurrent device that stops that flow. I can have a fully rated system where the overcurrent devices can interrupt the amount of fault current that they'll see, or I can have a series rated system. So the Article 100 of the National Electrical Code defines an interrupting rating as you see right here, right? So 110.9 interrupting rating requires the overcurrent device to have an interrupting rating not less than the maximum available fault current. And it has to be calculated, and it will vary based upon the system and the location, etc., of in the power distribution system. And there's similar requirements in 1910 303b4. And if you go to OSHA, what OSHA will tell you is that if you change your power distribution system over time, and you now have, say for example, you added motor loads, or a more common issue that I've seen in the past, you have an existing, say, a strip mall, and that last guy who was the it was a sandwich shop, right? So he leaves, and a new guy pulls in, and he says, "You know what? I am going to be making, I'm going to be making some iron in here. You know, I'm going to need have an arcing furnace. I'm going to need to have some presses." And they realize that he needs to increase the service size, right? So he calls the utility. Utility says, "Sure enough, we can do that. We'll change the transformer outside. We can change the service conductors." And when they do all of that work, you realize that they've increased the available fault current at that facility, and now all of the existing equipment is over duty, both from a 110.10 and a 110.9 perspective, interrupting ratings perspective. Then, obvious questions are who pays for it, right? But But in any case, put that all aside. OSHA is going to tell you that you need to make it right. You just don't, understand and see you have an issue and then walk away from it. You're going to need to address the issue. You're either going to have to change the overcurrent protected devices, you can reduce the available fault current, but you're going to have to do something to address that problem. This is what happens when you exceed the interrupting ratings of an overcurrent protective device. You have an unintended rapid disassembly in the field. That was a fuse, Class H
This
fuse.
is a serious misapplication.
Class H fuse that was rated 10,000 amp interrupting rating, and we put 50,000 amps through it. This is a 14,000 amp interrupting rated breaker, and we put 50,000 amps through it. We are misapplying both of
This
these.
is a serious misapplication.
Serious misapplication. You don't want to misapply the overcurrent protected device because it can fail on you in the field. It can. So minimum. So if you're not sure, you have an overcurrent device, you have a circuit breaker that's not marked with an interrupting rating, what the National Electrical Code tells us in 240.60 Charlie for fuses, that the minimum interrupting rating for a fuse is 10,000 amps. In 240.83 Charlie, we have the minimum interrupting rating of a circuit breaker is 5,000 amps. So if it's not marked, that's the minimum interrupting rating that you must assume on those overcurrent protective devices. The supplemental protective devices, none of this applies to a supplemental protector. And if you don't know what that is, that's another good topic for a 15-minute tech talk. All right, so we got 9 minutes, 16 seconds left. Let's talk about a fully rated system. In this example that we got here, I've got about 65,000 amps available at this power distribution panel board or switchboard, whatever you want to call it. And I've got 31,400 amps available of fault current. I've got a main breaker that has 65K, and all of the other breakers that are in there, or overcurrent device, well, let's say breakers because you're not going to find a 65K fuse. It's either going to be 100K, maybe a 10K, 200,000 amps. I think Class H 10K. But in any case, I have all of the overcurrent protected devices are rated to interrupt 65,000 amps. So 31,400 amps, they can do it in their sleep. Okay, not a big deal. When I series rate, that is when I take a main breaker or an upstream overcurrent protective device. And the reason I have the upstream labeled as an overcurrent protective device is because that can be a breaker or a fuse. You will never have a fuse downstream in a series rated system. You can't have a breaker protecting a fuse, and you can't have a fuse protecting a fuse. If you have two fuses in the system, it's going to be a straight rated or a fully rated system. In a series rated system, that upstream device can be a fuse or it can be a circuit breaker. Just be mindful of that. All right, so I have 65K interrupting rating breaker upstream, and I have 10,000 amp interrupting rated breakers downstream. You would say, well, if that downstream breaker sees 31,000 amps, remember the video, kaboom, right? Not the case, because in a series rated system, I test those devices together, and I make sure that when you see 65,000 up to 65,000 amps, both overcurrent devices are going to start to open, and just like Napoleon, we divide and we conquer. So the overcurrent devices together will interrupt, and neither of them will fail. So they work together as a team, whether it be a fuse upstream or a circuit breaker and a circuit breaker downstream. Now, 240.86 is the section, and I am using bada bing, bada boom, bada bang. 2020 version of the National Electrical Code. And if you look at 240.86 did see minor changes in the 2020 code, but the parent text, it says, where a circuit breaker used on a circuit having an available fault current higher than the marked interrupting rating by being connected on the load side of an approved overcurrent protected device. And the reason they added the word approved in there, because they're emphasizing that you have to have it as part of its listing. Those things are listed together. or approved by the AHJ. It doesn't say listing, but it will be approved for that location. So that means that somehow you need to show that it is adequate for that application. And it shall meet the requirements in A, B, and C. A is titled, this is your engineering supervision. B is your tested combinations. And C deals with motor contribution. We're going to talk about each of those. Now, in A, what's going on in A is you as the engineer are going to say, look, I don't have manufacturer's information. I got 2 Eaton breakers, and Eaton doesn't have the documentation that says these things are series rated, but you know what? I'm going to show that they're series rated. The key thing here is you have to be a licensed professional engineer, and you have to document and stamp do your PE stamp on those drawings or the documents. You have to present that to the AHJ because they're going to have to approve it. You've got to field mark it. And then you have to ensure, this is the key part, this is the most difficult part. You have to ensure the downstream circuit breaker that's a part of that series combination remains passive. And I'll tell you what that means and how you would get that done. You have to make sure that the downstream overcurrent device, those contacts don't start to open up. And let's say that your series rating to 65,000 amps. At 65,000 amps, you've got to show that those contacts aren't going to start opening up. How do we do that? Well, one way to do that is to take a look at the time current characteristic curve right here. I've identified 2 regions on here for you. One is region A, and in region A we call that what? The short time delay. In region A we call it a short time delay, and in that case, if your short circuit current is in that region, I know for a fact based upon that trip curve that those contacts are going to stay closed for almost up to 0.2 seconds. Anywhere from 0.2 seconds on, those contacts are going to start opening. So if whatever in my series rating pairs, if I can show that my upstream overcurrent device will clear that fault before I get into that region in area A, then I'm good. But here's the issue with that region A and the curve that I'm showing you. If your fault current is in that region, you're not exceeding the interrupting rating of that circuit breaker, right? But I needed a curve, and I grabbed a quick one, and I wanted it to show both of these regions. Now, on a big power circuit breaker, that little elbow there, then in region A, that little hockey stick, or whatever you want to call it, the hockey stick, this way, right? That could go on all the way up to the interrupting rating, and in that case, I know always up to the interrupting rating. If I need to increase the interrupting rating, I put a fuse or another circuit breaker upstream of it, and I know those contacts are going to stay closed for 30 cycles. As long as I clear within 30 cycles, I'm good. I'm going to protect that overcurrent device. But again, I will lose. Remember this. If both of those devices are opening, you're losing selective coordination as well. So be mindful that you're not going to get selective coordination per the definition and series ratings all in the same package. But in any case, this shows you now if my fault currents are in the area of B, I can't tell you if those contacts are going to open or not. So it would be very hard to series rate with a molded case circuit breaker. Power breakers, yeah, because they're holding their contacts closed for quite a bit. Okay, so in B, we have tested combinations, and you'll see we publish information. We put it in the series. This is the kind of booklet that we would find, that you would find with our equipment that's shipped. In our experience center here in Pittsburgh, we have the book that's mounted. It's put right on the outside of the panel. I don't know that you would do this in practice. Usually that information is tucked away somewhere else. But it is the documentation that we used, and UL has it online that shows the tested pairs. And how you read that document, you'll notice in this case I'm highlighting a column that underneath, right above there, up at the top, it says 65,000 amps. So that's 65 kA. If I put a GHB upstream and a BA or a BAB or one of those other type of catalog numbers downstream, they will series rate to 65,000 amps. And that GHB breaker has an interrupting rating of 65,000 amps. So together, they will achieve our series rated and interrupt up to 65,000 amps. That's how basically you use that table. So and let's talk about the motor contribution, which is in 24086C. This is important because This is how we test these breakers. We put two breakers in series. They both see the exact same fault current. And I know when I put 65,000 amps through both of them, they will both open and do their job. What happens when I add motor contribution downstream? What happens when I add motor contribution downstream? Whew, this thing doesn't even want to listen to me. Here's what happens. I've got the fault current coming from the upstream. It could be a utility. It could just be somewhere upstream in the power distribution system. I have motor contribution that doesn't go through the upstream circuit breaker. Where does it go? It goes through the downstream circuit breaker. So in the case of downstream motor contribution, I have more fault current going through the downstream circuit breaker than I have going through the upstream circuit breaker. That is not how I test it. So what the National Electrical Code gives you is the forgiveness of 1% of the interrupting rating of the lower rated circuit breaker. So if it's a 10,000 amps, 1% of 10,000 amps, that's the amount of motor contribution that I can have coming from downstream. Now the change they did in the 2020 code is they said motor circuits are connected between the higher rated overcurrent device, which is that upstream device, of a series rated combination, and on the lower end of the lower rated circuit breaker. So it's just basically telling you we're not talking about motor contribution where all of the contribution flows through both breakers. It's just that contribution that flows through the downstream breaker, but not the upstream breaker. All right. We've blown away that 15 minutes, but who cares, right? 110.22, identification of disconnecting means. Disconnecting means must be legibly marked to indicate its purpose, unless located in a range such that the purpose is evident, marking sufficiently durable to withstand. And that's the, in the tested combinations, we say C110.22 for marking of series combinations. And what it says in 110.22b, if you're doing an engineered solution, the equipment has to be marked, caution, engineered series combination system rated, say 65,000 amps. Identified replacement components are required, or just the word required. So what you want to do when you series rate a system, you've got to make sure people know that if you're going to replace that overcurrent device, you just don't run to the supply house and say, hey, I need a 22K breaker, or I need a BR or a BAB breaker. You need to look and say, what breakers am I allowed to put in there? And it could be in the engineered series combination systems, the engineer is going to have to tell you exactly which ones you can put in, because that individual has selected those devices specifically and they did an evaluation. You can't rely on the manufacturer for that information because we didn't engineer that one for you. If it's in 110.22, I'm going to go back there. In 110.22, it says, well, I might even have it on the next slide. I do. And for the tested pairs, this is what I was looking for. Now, this is what you get from me, the manufacturer. I'm going to have a booklet, and I'm going to show you, but you still have to do a label so that they know to come to my booklet to find out which ones will work, because I, as the manufacturer, did a test, and I've listed it as a series-rated system. I'm going to identify for you exactly which overcurrent devices can go upstream or downstream of the other when you do your replacements. So you've got to make sure you follow the series rated booklets or the documentation from the engineer, and make sure that you mark that equipment with the available fault currents. Now, one of the changes that failed in the 2020 code, there was an electrical inspector out in Denver, Jim Dorsey, I'll call him out. He had a great idea, I thought. Panel 10 did not think so. His issue was, and he saw just like I saw, there are a lot of people that forget about the motor contribution concept. They'll use series rated systems all over the place, and they never think. I did an educational program one time on this topic right here, and I got done, because we're really blowing that 15 minutes out of the water. But in any way, I got done with my presentation, and I had an engineer come up to me, and he goes, I need to talk to you because I think I have an issue. I said, well, what's going on? He says, I put together car wash. I have the design for car wash stations, and we do a lot of car wash stations, and I use series rated systems. And I'm like, well, okay, car wash. I'm thinking, I put my car through car washes too. I mean, you drive through them, a bunch of water sprays it, you get a little soap and suds, no big deal. And he reminded me, and we looked at the drawing, there are a heck of a lot of motors and big ones. You know, in West Virginia, we call these motors big ones. They are huge motors inside of a car wash. He series rated everything, and that was ungood. So he had to do a design change and had to address his issues. But that's not an uncommon thing to overlook. That motor contribution is a gotcha when it comes to series ratings. And why do we do series ratings? If I got all these things, I got to mark the equipment. I have to follow manufacturer's instructions. I limit what breakers you can put inside or fuses you can put inside of equipment. Why would I do that? Lower cost. I'm using a 10K breaker instead of a 65K breaker. I'm using a 22K breaker or instead of a 65K, whatever. And with that lower cost, and I tell everybody, no matter what you do, when I buy a tool, I'll spend money on a tool as long as I know I want that tool to be around. If I'm going to use a tool and be one and done with it, I'm going to go and find the cheapest piece of junk I can get, because I know once I'm done with it, I'm throwing it away and I'll never use it again. But if I'm going to use that tool over and over and over and over, I'm going to invest in a tool that I know that will last, right? Same thing with series rated systems, where you've got to cross your T's and dot your I's whenever you start to cut the costs. You may find that you bought this cheap tool, like maybe I bought a cheap saber saw or a circular saw, and I'm thinking, I'm only going to need it once, and I go to make my cut, and my cut's all wobbly. And you say, well, what the heck happened here? Why is that? Well, that's the quality that you get out of that piece of equipment. If you needed something more accurate or more suitable for that job, then you're going to probably spend a little bit more money. So series rated systems work in residential, maybe light commercial. The moment you start throwing motors in an application, you have gotten yourself out of a series rated system. All right. Well, I don't know how much further we went over the 15 minutes, but I'm going to need another clock. That's what I'm going to do. I need another button on here, and that counts up instead of down to identify how far over I went on my 15-minute tech talk. All right. So that was my 15-minute tech talk. I'm now going to check to see if there's anybody out there on TubeLand, because I did enunciate this one, and I may actually have people out there. I've got 7 people. Whoa! All right. Kindly explain ICU and ICS and ICW differences. Okay. Talal Kahan. Talal, where are you from, buddy? What part of the country are you out of? What part of the world are you out of? ICU and ICS and ICW differences. I am not familiar with what those. I don't know what those. I don't know what those acronyms mean, buddy. Brian, good seeing you. Nihad, hey Nihad, thanks for dialing in, sir. We know about protection coordination. All right, Talal. Hi Nihad, first time online. Brian Rock. Tropical storm left his town. Man, Pakistan, awesome, Talal. You'll have to explain to me, Talal, what you mean by ICU, ICS, and ICW. So help me understand those 3 acronyms, and I might be able to answer your question. 11 years experience of all the gas and power distribution systems. All right. Thanks for joining in, and you're in Saudi Arabia. That's kind of cool. Well, glad that you are joining in with us. I've got an audio. It says my stream rate's looking okay. Oh, I'm going to check. I'm on Facebook as well. I'm just double checking my stuff here. YouTube promoter. I got, let's take a look at on Facebook. I've been live for 24 minutes, so I didn't go too far over my 15-minute tech talk. Awesome. Okay, so any other questions? We got some people out there in YouTube land. I'm going to see if there's anything in my PowerPoint. All right. Remember, hit that thumbs up, and I know, Nihad, I should. 20-minute tech talk. mostly we've seen on air circuit breakers written at ICS and ICU. ICU current. Ultimate braking capacity. Okay, so we've got differences in ICU. ICS is service short circuit braking capacity. ICU, you see me. ICU is really a maximum prospective fault which a circuit breaker can clear, which is the interrupting rating. It might be an international standard. This could be something that is in the international world and not in the UL or NEMA world. After clearing fault, this point is particularly important to the circuit breakers when the ICS is lower than the ICU. It could be that you have an interrupting rating and then you have a withstand capability. Maximum prospective fault current which the circuit breaker can clear and still remain serviceable. So ICS is like the interrupting rating that I'm talking about. Okay, short circuit withstand time. So a withstand, whenever on the big power breakers, you're going to see power breakers will have a withstand rating. And I know a lot of cases I'll say, well, breakers don't have a short circuit current rating. Where in reality, some of our power breakers will have what they call a withstand rating that basically I can hold my contacts closed for, say, up to 30 cycles. And they'll call that how much current I can withstand, right? And for, say, 30 cycles. So in some cases on your power circuit breakers, I will have a withstand rating, or your larger breakers. You're not going to have that on a molded case circuit breaker. But that again, you could have those contacts can be held closed all the ways up to its interrupting rating. So that's apparently what the ICW is, and then ICU is your actual interrupting rating, if that makes sense. Yeah, Nihad, I believe that is an IEC terminology, and I'm not familiar with it either, but I just did, I just did a quick look, and I felt comfortable with, and I know it's two terms that are out there, so I can see it mentioned numerous times online, but I'd have to do a little bit more homework for you, Talal. Hopefully I said that right. From Pakistan, working in Saudi Arabia. So thanks for dialing in today, though. I really appreciate that, and for what you're doing across the globe. We're engineers are all over the place, and that's a good thing. And Brian Rocky's not familiar with that either. So Nihad, let's see what we got. All right. Boy, Brian, you're in the office, going out there on that limb, man. That's good. Glad to hear you're back in the office, buddy. They still won't let me travel, and I got into the Experience Center last week. We did some filming, which was kind of cool. And we're going to have this, I think next week I'm going to be doing a program with our Experience Center folks, Dan Carnevale, Eric Hurd, and Santino. We're going to be doing something, I believe, on power quality, so you're going to want to get that in there. Mostly they said ICS and ICU is equal. So, and what I'm thinking, Talal, is if ICU is the interrupting rating and ICS is related to the withstand rating, then you'll have a withstand rating that would be equal to the interrupting rating. And that would be an important thing to know, that I can withstand that much current. You got to know how much you can interrupt, and you should know how much current. In fact, I don't know if I have that. I'm not sure if I have that trip curve on this computer. I got a new computer over here. So in some cases, your withstand rating will be less than your interrupting rating. So what that means is on the trip curve, in fact, it was in my presentation. Let me bring up that curve for you, Talal, and this might help you. Now this is a molded case circuit breaker, so I'm going out on a limb here, but just bear with me. I got to hit the right button. Here we go. All right, so this is for you, Talal. Boom. All right, so in this picture, what I'm showing is, you see that knee, which is this way, right? So I have the breaker that comes down and then over this way. That knee, if this was a power circuit breaker, that would be a short time delay. The interrupting rating could be much higher. In some cases, that elbow does not come down to the 0.01 seconds. It goes all the ways out to the interrupting rating of that circuit breaker. That would be a withstand rating, a short time delay setting that ends at the interrupting rating, and they're both the same. In some cases, like in this case here, the interrupting rating is much higher, but the short time delay doesn't go all the ways to the interrupting rating. I think that is what they're talking about, in where you could have an interrupting rating that is equal to the withstand rating, and you could have a withstand rating that is less than the interrupting rating because of the capabilities. Because remember, a circuit breaker, the hardest part for a circuit breaker, hey, look, I got 13 minutes back on. I got another 15 minutes. So remember, a circuit breaker is the most difficult part for the breaker is not necessarily opening, it's holding those contacts closed. And that's why we put an instantaneous. UL 489 for circuit breakers does not require me to put an instantaneous in a circuit breaker. That's why I can have power circuit breakers or an insulated case and whatnot. I can have a circuit breaker, a large circuit breaker that doesn't have an instantaneous pickup, because there's no requirements in the standards for me to put one in. I put it in because I want to make sure I don't have chatter of those contacts. I'm going to tell that puppy to open when I know that the fault current, based upon the fault current and the amount of current that's flowing through that breaker, I want those contacts open, because I could start to get chatter, because if I'm trying to hold it together, it's not rated for that. So that's why you'll see curves like this that have a short time delay for a certain period of time, but then it goes to instantaneous, because I want to pull that current off and stop it from flowing so that I protect myself, I protect the surface of those contacts and everything else inside that circuit breaker. All right. Well, we went way over our 15 minutes, but I think it was a good discussion. Hopefully this helped out, and I'm going to take that 12 minutes off, because that just makes me look bad. Another 15 minutes. I'm going to add another timer that I hit that starts going up when I go over 15 minutes. All right, everybody, thank you for tuning in for this 15-minute Tech Talk, this Live at 5 Tech Talk. Maybe that's what I'll call it, the Live at 5 Tech Talk. That way I'm not tied to 15 minutes. We'll see what happens. Okay, thanks for tuning in. Stay safe, stay healthy, and thanks for what you do for electrical safety and all that jazz. I'm going to thanks for your info, Tom. Yep, sure thing, Brian Rock. I'm just looking at Talal. Kindly check this. I'm not sure. I will, you know what I'll do, Talal? I'll do some investigation. I've got some people that are very familiar with the IEC side of the world, and I'll make sure that my explanation, it makes totally sense. I believe that's exactly how that's being referenced, but I'll verify that for you, and maybe that's another 15-minute Tech Talk. All right. Thank you for tuning in, and I'm going to just double check. You're good. Don't worry about going over time. I know. I'm going to check, make sure there's no comments. Checking out there on Facebook. And I did get something on LinkedIn. I got 2 messages on LinkedIn. What are these? Somebody's selling me something. Hello, hope you're well. Which are not enough for monetization. Grow up your business. All right, somebody wants to help me monetize. I'm not interested in monetizing on YouTube. I'm not doing this for money on YouTube. I am doing this because it's the right thing to do. Now, all right, Alice Fitzwater, everybody. All right, thank you very much. I'm going to sign off then, since I don't have any other questions. Take care, Talal. Enjoy Saudi, and take care of yourself, and stay safe and stay healthy, my friend. We'll see you. And I'm going to shut this down. I gotta go back to. I gotta shut down on this one. All right, got Pittsburgh in the back. That's the point. Signing off.